Let's work out the problems of exercise 2.2 in polynomials. Before that, let's learn some of the points. Let f of x be ax square plus bx plus c. It's not be a quadratic equation. Polynomial. Let alpha and beta be its zeros. Then by factor theorem, x minus alpha and x minus beta are the factors of f of x. Therefore, let f of x be constant k into x minus alpha into x minus beta. Now we have to find the product, sum and the products. So we saw that alpha and beta are the zeros of the quadratic equation. That is, if alpha and beta are the zeros of the quadratic polynomial ax square plus bx plus c, where a is not equal to 0, then the sum of the zeros is alpha plus beta, which will be equal to minus b by a, which is equal to minus coefficient of x by coefficient of x square. So this is the very important formula to find the sum of the zeros. To find the product of the zeros is equal to alpha into beta, which is equal to c by a. It's nothing but the constant term divided by the coefficient of x square. So this is what we are going to use in this exercise. So let's move to the exercise problem, exercise 2.2. Problem number 1. Find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficients. So first problem is x square minus 2x minus 8. Let p of x be equal to x square minus 2x minus 8. By the method of, we have to find the factors. So by the method of splitting the middle term, we can find the factors. X square minus 2x minus 8 can be factorized into minus, this 2x can be split up into minus 4x plus 2x, which gives minus 2x minus 8. Now taking the middle common factor x outside from these two terms, so x into x minus 4, same x minus 4 must be here, and here we will get plus 2. So for these two terms we are taking 2 outside and x minus 4 will be inside, because these two terms must be equal. So the factors will be x plus 2 and the common will be x. Taking x minus 4 in common, will get x minus 4 into x minus 2. Next, for zeros, to find the zeros, for zeros of p of x will be equal to, put p of x is equal to 0. So p of x minus 2 into x minus x plus 2 into x minus 4 is 0. x plus 2 is 0, x is equal to minus 2, x minus 4 is 0, x is equal to 4. So the zeros are of p of x are 4 comma minus 2. So we have to find the sum of its zeros, which will be equal to minus of coefficient of x by coefficient of x square, which will be equal to, the polynomial is x square minus 2x minus 8. So here 1 is the coefficient 1x square. So 1 is the coefficient of x square, minus 2 is the coefficient of x. So it is minus 2 will be the coefficient of x by 1 is the coefficient of x square, which will be equal to which is nothing but the coefficient of x by coefficient of x square. So here we have to find the product of its zeros can be given as constant divided by coefficient of x square. Here in this equation the constant is minus 8, which is equal to minus 8 divided by coefficient of x square is 1. That's it. Now we have found out the zeros, sum and the product of the zeros. Problem number 2. 4s square minus 4s plus 1. Let p of s is equal to 4s square minus 4s plus 1. By the method of splitting the middle term, we can have 4s square minus 4s plus 1 is equal to 4s square. We can write minus 4s as minus 2s plus 1. So from these two terms, let's take 2s in common. We will get 2s minus 1. Here again we will take the common term 2s minus 1, and we have minus 1. We get minus 1. So these two are common terms. So taking 2s minus 1 in common, we have 2s minus 1 here. So to find the zeros, for the zeros of p of s, p of s is equal to 0. So 2s minus 1 into 2s minus 1 is equal to 0. 2s minus 1 is equal to 0 is a term. 2s minus 0 is equal to another. S is equal to 1 by 2, or s is equal to 1 by 2. So s is equal to half comma half. So the zeros of p of s are 1 by 2 and 1 by 2. Here we have to now find the sum of its zeros, which is equal to 1 by 2 plus 1 by 2, which is equal to 1. Coefficient of s, that is minus of coefficient of s by coefficient of s square, minus of minus 4 by 4. Product of its zeros will be, because we know the polynomial is 4s square minus 4s plus 1. Here the coefficient of s is minus 4, therefore coefficient of s square is 4. Product of its zeros will be equal to constant by coefficient of x square, which is equal to Here constant is 1 divided by 4. Now next problem 3. 6x square minus 3 minus 7x. Let p of x be equal to 6x square minus 3 minus 7x. For zeros of p of x will be equal to 0. So 6x square minus 3x minus 7 is equal to 0. This can be written as 6x square minus 7x minus 3 is equal to 0, which implies 6x square splitting the middle term. This can be given as minus 9x plus 2x minus 3 is equal to 0. So taking common 3x in common, we get 2x minus 3 plus 1. From these two, 2x minus 3 is equal to 0. Taking through 2x minus 3 in common, we get 3x plus 1 equal to 0. 2x minus 3 is equal to 0, or 3x plus 1 is equal to 0. 2x equal to minus plus 3, x is equal to 3 by 2. Here 3x is equal to minus 1, x is equal to minus 1 by 3. So the zeros of p of x are 3 by 2 and minus 1 by 3. Now we have to find the sum of its zeros, which will be equal to minus coefficient of x by coefficient of x square. So the polynomial is 6x square minus 7x minus 3. Here minus of the coefficient of x is minus 7 divided by coefficient of x square is 6. Finding the product of its zeros, which will be equal to constant divided by coefficient of x square, which is equal to, here constant is minus 3, so minus 3 by 6. Problem number 4. 4u square plus 8u. Let p of u is equal to 4u square plus 8u. For zeros of p of u is equal to 0. 4u square plus 8u is 0. 4u into u plus 2 is equal to 0. So 4u is equal to 0 or u plus 2 is equal to 0. Here u is 0 by 4, u equal to 0. Here u is equal to minus 2. So the zeros of p of u are 0, minus 2. Now finding the sum of its zeros will be minus coefficient of u by coefficient of u square. So the polynomial is 4u square plus 8u, which is equal to minus of 8 by 4. To find the product of its zeros, which is equal to constant divided by coefficient of x square, is equal to constant here is 0, so 0 by 4, which is 0 by 4, which is equal to 0. Problem number 5. T square minus 15. Let p of t is t square minus 15. For zeros of p of t, put p of t is equal to 0. T square minus 15 is 0. This is in the form a square minus b square is equal to a plus b into a minus b. We can write this as t square minus root 15 the whole square equal to 0. So one will be t minus root 15 as 0. The other one will be t plus root 15 equal to 0. T equal to root 15 is here. T equal to minus root 15. The zeros of p of t are root 15 and minus root 15. Now we have to find the sum and the products. Sum of its zeros will be minus coefficient of x by coefficient of x square. The equation is given as t square minus 15. Here coefficient of t square is, this is t. So coefficient of t square is 1, coefficient of t is 0. So this will be minus 0 by 1. And the product of its zeros will be equal to constant by coefficient of t square. Here the constant is minus 15 by coefficient of t square.